Hello everyone, welcome to our next lesson. Today we're going to be looking at inflection points. And inflection points means when the second derivative is equal to 0 and that there is a change in the sign for the second derivative. Now there's different kinds of stationary or different kinds of inflection points. One is a stationary inflection point where the first derivative is equal to 0, and the other kind is where the first derivative is not equal to 0. So let's look at an example. Suppose we have x to the power 4 minus 4x cubed plus 5. If I found the first derivative, f prime of x, that's equal to 4x cubed minus 12x squared plus 0. And the second derivative, f double prime of x, is equal to 12x squared minus 24x. Now, if we're trying to find an inflection point, we have to have the second derivative is equal to 0. So 0 is equal to 12x squared minus 24x. 0 is equal to 12x, x minus 2. And therefore, x is equal to 0, x is equal to 2. So this is possible inflection points. So we're going to test it out to see if they are inflection points. So 0 and 2. So let's first test out a number that is lower than 0. Let's say negative 1 or negative 10 or negative 200. And we can see that this is a positive. So when I put negative 2 into the second derivative, it becomes a positive number. Now I'm going to put a number between 0 and 2 into the same second derivative. Let's use 1. So 12 times 1 minus 20, that's negative. And then I'm going to put a number that's bigger than 2. Let's say a billion. So 12 times a billion squared, that's going to be a very big number. A lot bigger than minus 24 times a billion. So that becomes positive. So it goes positive, negative, positive. Now I never figured out what the numbers were for these. I just figured out whether they're positive or negative. And because it's changing from positive to negative or negative to positive, we know, because of the second rule, that it is an inflection point. Now the question becomes, what kind of inflection point is it? Is it stationary or non-stationary? If the first derivative for this point is equal to 0, it's stationary. If it doesn't equal 0, it's non-stationary. So let's test the first derivative for when x is equal to 0. So f prime of 0 is equal to 4 times 0 cubed minus 12 times 0 squared. That's equal to 0. And therefore, at x equals 0, we have a stationary inflection point. Stationary inflection. Okay? At f prime of, what was my other point, 2, and I put it into the first derivative, we get 4 times 2 to the power 3 minus 12 times 2 squared. 8 times 4 is 32 minus 4 times 24, negative 48. This is not going to equal to 0. Does not equal 0. And therefore, this is a non-stationary inflection point. Okay? So, last thing we could do for this, because it wants you to find the point. We know what the x value is, it's 0. Now we just have to find out what the y value is. And that's simply putting it into the formula. So for the first one, you've got the point 0, 5. And that gives you your stationary inflection point is at 0, 5. And the other one was when x is equal to 2, you plug it into the formula, and you get 2 negative 11, I believe. So at 2 negative 11, you've got a non-stationary inflection point. Hope that helps. Have a good day.